Hey guys, it's Miss Richards. Today we're just going to do another video. I have a few people out, so they need to see what we're doing in class. So I wanted to make a video for today. First off, again, everything I do, I put in the planner. And then if you go to the planner, you find the day that you're out or the day that you want to go back and rewatch. Click on the topic. So like today, I haven't done this yet, but today what I'll do, I'll go ahead and do this now. I'm going to put a video in right here. I'm going to put this video in Canvas so you can go back and watch it if you need to. Okay, it'll be right there under Tuesday Say. Again, today we're doing rational and irrational numbers. Tomorrow we're going to do some application stuff. The homework's going to be the test review. And then Thursday we're going to go over the test review. And then you're going to have a practice test that will be uploaded right here. If you do not do the practice test or the test review, you will not be able to remediate the test. Again, if you do not do these two things, if you fail the test, you will not be able to remediate the test. You need to do the study guide or the test review, and you need to do the practice test. Okay, so for today, I want to look at your stuff from yesterday. So if you get out your homework, let's see. Yesterday was the 16th. I'm just going to quickly go through this. If you want to pause the video, you can. And guys, you know, the test, so these problems were difficult. The test does not go into this much detail, okay? So if you can handle like number 6, number 5, you're going to be fine for the test. Okay, I'll give you a minute for these. You need to pause the video, pause the video. Number 1, 18 square root 2. Number 2, 5 square root 2. Number 3 is just 6. Number 4 is negative 40. Number 5 is 12 square root 5. Number 6 is 20x square root x. Number 7, 5n squared square root 6n. Number 8, 12a squared square root 6. Number 9, negative 126 r squared square root r. Number 10, negative 56 x squared. Number 11, we did this one together, 5 square root 3 plus 3. Number 12, 2 square root 30 plus 4 square root 5. Number 13, negative 6 square root 3 minus 9 square root 2. Number 14, negative 5 square root 30 plus 3 square root 2. Again, on any of those that had two numbers, you could have switched the order around. Like on number 14, you could have had 3 square root 2 minus 5 square root 30. That works as well. Just because you change the order of an equation or the order of an expression doesn't mean it's different. Number 15. 18 square root 5 minus 30 square root 3. That was 15. Number 16, 20 square root 42x plus 140x square root 6. Number 17, 3 square root 14x minus 2x square root 7. Number 18, 7n cubed square root 6n plus 6 square root 2n. Number 19, 3 square root 2v plus square root 30v. Number 20, 5 square root 21r plus 7 square root 3r. Number 21, negative 16 plus 12 square root 3. Number 22, negative 30 plus 13 square root 5. Number 23 is 5 minus 13 square root 5. Number 24 is just 2. And when you get to algebra 2, these are actually called something called conjugate. You'll learn about that. Number 25, we did this one together. Negative 40x plus 5x square root 10 minus 4 square root 10x plus 5 square root x. Number 26, negative 9k plus 19 square root 3k minus 20. Number 27 is 27 plus 17 square root 3. Number 28 is 6 minus 9 square root 10r plus the square root of 10 minus 15 square root r. Okay, I'll just go back through these in case you missed one. And it's okay if you struggled on this. These were difficult. We haven't done math like this in a long time. But basically it boiled down to you got to multiply. What's on the outside stays on the outside, inside stays on inside. and then you simplify. Okay, so we should have done that. So now let's look at the notes for today. So today we're going to talk about rational and irrational numbers. Okay, let me get my pen. So for rational and irrational numbers, an irrational number is a real number that cannot be written as a fraction. Okay, these are all examples. So 1.5, you can write that as a ratio of two numbers. That's rational. Pi is irrational. There's no ratio. So the way I differentiate between these two, an irrational number is a decimal that does not repeat, and it does not stop, and it does not have a pattern, kind of like an irrational person. It goes on and on forever, and it doesn't make any sense. Well, that decimal goes on and on forever. There's no pattern. It doesn't stop. It doesn't make sense. Okay, so let's fill out this chart. We've got real numbers. That's everything here. Now you'll learn about imaginary numbers in Algebra 2. And then we've got two bubbles. The first bubble is going to be rational numbers. These are numbers that can be written as a fraction, written as a decimal that stops or terminates. Fraction. This is a decimal that has a pattern. That's still rational. You can have integers. You can have -5. You can have square root 49 because the square root of 49 is just 7. Okay, and then of course 0, whole numbers, natural numbers, all of those are rational. Irrational is the smaller bubble. Pi is very famous, and you have square root 2, square root 3, square root 10. Anytime you see those numbers, it means it's a decimal that goes on, doesn't have a pattern, doesn't stop. Okay. I'm going to move down. The bottom, the difference between rational and irrational numbers. So the first box, these are rational numbers. So it is expressed into the ratio where both numerator and denominator are whole numbers. It includes perfect squares. The decimal expansion for rational numbers executes finite. That means it stops. Or recurring decimals, that means it has a pattern. Like 4.2 or 3.7171. That pattern repeats, okay? You can't see. And then irrational numbers. It is impossible to express an irrational number as a fraction or ratio of two integers. It includes thirds, which is over here. We'll talk about that in a minute. And then here, non-terminating, that means it doesn't stop. Doesn't stop. And non-recurring, no pattern. Decimals are executed. I forgot the end. There we go. Okay, what is a surd? A surd, the values in the square root that cannot further be simplified into whole numbers or integers. Examples would be square root 2, square root 3, square root 5, kind of like the numbers we see in square root form up here. Okay. All right. So turn the page. You should have gotten everything on page 1. Page 2, we're going to talk about what happens when we add or multiply with rational and irrational numbers. Okay. So again, the most famous irrational number is pi. Anytime you see pi anywhere in the problem, unless you have pi over pi, that would just be 1. If you have pi over pi, that would be 1. But you're probably not going to see that. All right. Properties of rational and irrational numbers. Here are some properties based on arithmetic operations, such as addition and multiplication, performed on the rational number and irrational number. So the sum, if we're adding, of two rational numbers is also rational. So if we had 1/2 plus 1/3, that gives us 5/6. All of those are rational. Okay. Number two, the product, when we're multiplying, the product of two rational numbers is also rational. Okay, so if you had 1/2 times 1/3, that's 1/6. Again, all of those are rational. You go down. Number three, the sum of two irrational numbers is not always, whoops, irrational. You go either way. When you're adding two irrational numbers, sometimes it could work out and it could be rational. Okay, sometimes it's irrational. So it could go either way, basically. Example, if we had the square root of 2 plus the square root of 2. So again, imagine you've got a 1 here and a 1 here. 1 plus 1 is 2. 2 square root 2 is still irrational. All right, number 4. The product of two irrational numbers is not always irrational. Okay, so if we had an example, square root of 2 times the square root of 3, well, 2 times 3 is 6. Square root of 6 is still going to be irrational. But if you had square root 2 times square root 2, that's the square root of 4, which is 2, which is rational. So it could go either way, okay? When you are adding or when you're multiplying with two irrational numbers, you just have to see what it is. You have to do the math and see, okay, is my result rational? Is my result irrational? So it just depends. All right, so let's do some examples. We're going to turn the page over. And I don't know, I need to figure out why they want to use Q for rational. If you use R, I'm okay with that. Like if you want to use R, I probably am. It makes more sense to me. So on these, you're just going to say if it's rational or irrational. Like number 1, the square root of 47. If you were to type that in your calculator, the square root of 47, you type it in, and then down here above enter, you see these two arrows. If you hit that button, gives you a decimal. There's no pattern, it doesn't stop. So that would be irrational. So we're going to put an I. If it can be expressed as a fraction, it's rational. Okay. So I want you to pause the video. And guys, I want you to try to get through 20. I'll give you a couple of minutes. So pause the video and see how far you get. Okay, we should have paused the video. So I'm just going to go through these. Number 3, that's rational. It can be expressed as a fraction. The square root of 96. Let's just see. Square root 96. And then hit the arrows. Yeah, that doesn't stop. That goes on. So that is irrational. It didn't have a pattern. It can be expressed as a fraction. It's rational. Square root of 84 is going to be irrational. -9 is rational. Square root 72, irrational. 0, rational. 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 Square root of 59 is irrational, and that's further down. 20, number 9 is rational. Okay, so let's do a couple of these. Negative square root 64, well, that's just -8. That's rational. The square root of 1600 is what, 400? Yeah, so that would be rational. No, 40. 40, that would be rational. Yeah, 40, yeah. And then number 3, the square root of 160, guys, that's going to be irrational because when you type that in, you get 12.649111064. That's irrational. Square root of 144, that's just 12, so that's rational. Square root of 125, when you type that in, you get, hold on, 5 square root 5. When you toggle that and you get your decimal, it's going to be irrational. Negative square root 340, that's irrational. 1.96. So if you're ever not sure, just type it in. So let's try this. So the square root of 1.96 is 1.4. Well, that's a decimal that stops. That's rational. And then number 8, negative square root, so negative second square root 0.09 is negative 0.03, which is just rational. Okay. So we did those examples together. All I want you to do for homework is the back. Okay. You've got 9 questions. You're trying to decide, if it's rational or irrational. And then you're going to put your answers at the bottom, and we will check this at the beginning of class tomorrow. Make sure, okay, when you're done with this, this is the homework. So practice 3, this is the homework. When you're done, go to Canvas. Today is Tuesday. Again, I'm going to upload this video here soon, shortly. When you're done with the assignment, you're going to go here. It's Unit 3, 1017, Rational and Irrational Numbers, and you're going to submit your stuff here. Okay. I hope everyone has a great day.